Welcome to online lectures by CA Studies. For more lectures online, please do visit castudies.lk.
Hi everyone, welcome back. So we will be continuing with chapter 1, which is Introduction to Modern Manufacturing Environment. So previously we discussed on what modern manufacturing costings are and what are the JIT manufacturing techniques and what are the benefits of them, all of it. So today we will be continuing with the problems faced by JIT and then so on with concepts like Kaizen, stuff like that. So your first chapter, Introduction to Modern Manufacturing Environment. Actually this chapter is only theory based, okay? So which means you mainly need to remember for your MCQ question. Okay, so that's why I emphasize on each and every word that is needed to remember, because sometimes it might get tested for your MCQ. Okay, so yeah, so chapter 1. Right, let's continue with our discussion today, which is on problems associated with JIT. Alright, the problem number 1. Okay, they say you cannot predict demand. Cannot predict demand. Why do they say so? Because we learned that as part of JIT we have the pull system, right? Pull system where we base our decision based on the customer. So if the customer doesn't demand, we will not have production, no production, and then no operation, which is connected with suppliers, right? So it's now that is when there's no demand, but that such scenario never happens, right? Otherwise they won't implement practically a JIT system. So what they're saying is, however, we can't predict the level of demand. That's the issue, because things are uncertain, just like the pandemic. Nobody predicted the pandemic, but it occurred and many changes took place. So same like that, we have that same problem with JIT. Next is they are more vulnerable to supply chain. Vulnerable to supply chain means they'll give more pressure on suppliers. That's the meaning, right? On suppliers, they'll give more pressure in order to meet the demand of customers, because everything happens at the same time. So that makes it more like, it can disrupt the relationship with supplier at the same time, right? So you need to be so those arouse such drawbacks when we have a JIT system. Okay, then you have okay, they say here JIT was designed at a time when all of Toyota's manufacturing was done within a 15-kilometer radius. So wide geographical spread makes it difficult, meaning you can't have JIT when you have multiple branches, because it's very difficult to coordinate between them, right? So JIT was actually implemented first by Toyota. So Toyota, they operated within a 50-kilometer radius. Within that only they implemented their JIT system. But you're going to, if you copy the same system, you should ensure that your branches are close to you. Then only you can get the maximum benefit out of it. Okay. So, but so for a multinational company, okay. So not suitable for multinational companies, right? Or companies with multinationals, or companies with wide geography. Okay. So these three things you got to remember very carefully, because they might test for 2 to 3 marks, or when they ask, sometimes they might ask you evaluate the JIT system in this scenario. Then you will have to remember your benefits and then argue with your drawbacks as well. Alright, now let's look at the terms that are used mainly within a JIT system. Okay, because these terms determine how effective and efficiently can we maintain a JIT system, right? So I would like to show you all. Okay, so first they talk about manufacturing cycle efficiency. So it's very obvious, right? So let's say under JIT you got manufacturing cycle efficiency, and under that you got customer response rate, right, and manufacturing, you got manufacturing cycling time, manufacturing cycling time. You could refer your textbook for these in detail, but this is like the summary version of it. Okay, so you see, efficiency of a manufacturing cycle is determined by the customer response rate and the manufacturing cycle rate, right? So how well your customer responds in terms of demand and in terms of customer return, and how well your manufacturing cycle responds to such customer demand. Okay, so it's interlinked, and those two together make up the efficiency of the manufacturing cycle. So you got to remember such key terms. They might test it within your MCQs. So what they define as efficiency in terms of the manufacturing cycle is proportion of time during which value is added during the production process, and that is calculated as processing time over waiting time, right? I would say P for processing over processing time plus waiting time plus moving time plus inspection time. So basically they see how long, what is the proportion of processing in terms of the total production time lapse, okay, in terms of wait, move, inspection and production itself. So yeah, so you need to remember this formula. Okay, the close, so they say if you get a ratio, now this is a ratio, no? So if you get it close to 1, okay, maybe like this, close to 1, it means your production operation is very efficient. Okay, so as the ratio increases, your work in progress falls. Okay, your work in progress falls as your ratio increases. Why? Okay, so let's start to look at with regard to manufacturing cycle efficiency. Okay, so this is interesting. Now I just said that your work in progress investment will fall as your manufacturing cycle efficiency increases, right? So let's see how, I'll show you all how this efficiency ratio works and why WIP falls, and then how it contributes to the overall efficiency. Okay, so what I say is, now let's imagine process time is let's just imagine, okay, let's say 5 minutes. I'm trying to take very simple numbers, okay, because this is basically a mathematical calculation. So you just need to know Okay, let me first put down the figures so that you get the idea in the end. And then, waiting time, let's say 10 minutes. And what do you call? Moving time, another 5 minutes, let's say. And inspection time, okay, another 10 minutes, let's give it. Okay, so then if you put it into the formula, you will be doing 5 divided by 5 plus 10 plus 5 plus 10. It's very simple. Okay, so then how much? 15. So it's a simple calculation. So 15 plus 5 plus 10, 5 divided by the answer is 0.16. Okay, now, and I'm going to take a second situation where there is no waiting time, okay, no moving time either, but you have some inspection time of 5 minutes. Okay, then what will be your ratio? And then your process time remains same at 5 minutes. So your ratio is 5 plus nil, and then 5. So you get how much? Divide by 10. So the ratio will be 5 over 10, which is 1 over 2, 0.5. Okay. Now you see here, they say your efficiency will increase when your ratio grows near 1. So, first situation where you had waiting time and moving time and even inspection time, your ratio was 0.16, which was way far than 1. But when you see the second situation, your process time was same, but you had no waiting time and no moving time. But because of quality checks, let's say you had an inspection time of 5 minutes. Then what happened to your ratio? Your denominator value decreased compared to this. Right? As a result, your ratio increased to 0.5, which is closer to 1. Right? Which is closer to 1. Let's assume there is no inspection time. Then what will happen? In an event where there is no inspection time, okay, then it's so obvious, right? So your process time will be your total time as well, which will be equal to 1. So this is the maximum efficiency point, okay? But this is like never, practically it is not possible because all resources are limited, and there's you can't really expect certainty in your production processes, right? Hence, the point here is, so the more you move to 1, which is when there is no waiting time and no moving time, you fully produce whatever you input, right? You fully process whatever is input. As a result, there is no work in progress. Okay, because totally you will produce what is being put. Nothing is waiting and nothing is moving. The waiting and moving items are only work in progress. Okay, so if there is nothing waiting and nothing moving, so you don't have your work in progress. And as a result, your work in progress drops as you move towards your efficiency. So here your work in progress will be low. Why? Because your MCE, which is manufacturing cycle efficiency, was high. Okay. So this is the theory behind a manufacturing cycle efficiency. Then they say, as you try to reduce this waiting time and moving time, okay, you go towards maximum efficiency. As you go towards maximum efficiency, you tend to, what do you call, reinvest in new machinery, stuff like that. Why? Because you want to increase your efficiency. Now, so this is, now this 5 minutes, I'm just taking it for an example. But say multiple machines are there. So then, you know, the process times will be increased, right? And all of these will be very high, practically. So the more you try to increase efficiency, the more investment cost you incur in reinvestment or redesigning your machinery, right? So so they say, but however you get a net benefit. Even though you reinvest in your machinery, you get a net benefit, because the more you are efficient, the more profits you gain, because the lower work in progress you have. Okay, so with that, let's see. Okay, they give a relationship between manufacturing cycle time and JIT. Okay, let's look at it. So the reduction in manufacturing cycle time is a key phase in the introduction of JIT. So the less time you take, actually the less time you take for manufacturing is more prone towards JIT system, right? Because you take less time, no lead times. Okay, so that is what they say. Next, they say JIT has advantages in certain manufacturing environments, but the benefits of increasing MCE apply to all organizations, irrespective of whether they also use JIT. So, okay, MCE, this MCE formula, okay, which is this, right? This is not only used for JIT. It is used for all organizations. It is all manufacturing organizations who do not use JIT also have to follow this. I mean, it's good to follow this manufacturing cycle efficiency. Alright. So that is what they say. Just as JIT can be applied to the supply chain, so too can the concept of MCE. So the same thing. They say that, you know, basically you try to focus on reducing these waiting and moving times, and even the inspection time as well. Like, how do you reduce inspection time? Maybe you will have more efficient processes, right? More qualified people to check your production process. Then they can check faster with easier techniques. So that reduces the inspection time. And then waiting time, moving time, all of those, like the more efficient your machinery is, the lesser the waiting time and the moving time will be. Okay. Alright. So then, alright. So now we spoke about just in time totally. Now let's see how just in time differs from just in case scenarios. Alright, now let's look at what is the difference between just in time and just in case. Okay, so I discussed initially that just in case is when you have, like, you know, uncertainty and you don't rely on that certainty, right? So let me quickly show you all the differences, so that so it might be tested again in one of your MCQs. So it's good to know the key differences between just in time and just in case. It's just super easy. Just the opposites of just in time are just in case. Alright. So just in time you got low inventory level. It's a very, very important point for just in time. Because the primary reason for not having inventory is to reduce cost, right? So if the just in time enables such low inventory because they don't let any time gap between any production lines. So, as a result, your holding cost will be low, right? Then risk of low quality items will be low. Why? Because you are not storing anything, right? So you have to develop your advantages based on the concept of having low inventory level. You already know that because it's a very practical thing. But don't forget that JIT always have low inventory level or no inventory level, low or no, right? But no is not practical because as we discussed in the problems of JIT, right, demand can be uncertain and we may not be able to predict demand properly. So companies don't want to lose out just because they have a JIT system, right? They will have at least a minimum level of inventory that they are ready to bear the cost of. So that's why they say low inventory level, okay? But just in case, right? Just in case, I'll write the full term, just in case you got high levels of inventory, right? High levels of inventory or medium, high or medium, right? So, because they want to reduce their uncertainty. They don't believe in JIT. That's the reason they have high level of inventory. The opposite. Okay? That's a very important point you need to remember when it comes to the entire JIT system. Okay, next, develops with the inventory low production holdups or maybe, okay, so due to it may, so they say either low production holdup, right? Because you have some inventory now, so sometimes, you know, you might have to hold your inventory, hold your production till you receive new inventory and so on, like, but it is not a major drawback, but it's just a feature, okay? And then you got so here they say you have no production holdup, right? Why? Because you have inventory to continue your production process. So since you have inventory to continue your production process, you don't need to hold up your production, right? Okay, good. And then you have low storage cost on JIT system. That is connected again with low inventory level, which I said holding cost is low. And then you have less working capital management. Why? Working capital management because less cash is tied up in your inventory. Why? Because you have low inventory levels. So less cash tied up in low inventory level will simplify your working capital management, releasing more cash to your business. But on the other hand, just in case they have high storage cost, right? Because they have high levels of inventory and they have high working capital requirement. Okay? Working capital requirement because they have a lot of cash tied up in their stock. So, you know, so that makes it difficult for them to manage their working capital on a day-to-day basis. Right. So, with that, we finish just in time and the concepts behind it, the benefits, the drawbacks, and all the just in case, the differences. So by now you must be very familiar with all of your key terms used in this, okay? Because I emphasize on the key term because I believe it will be tested for your MCQ or for a 5-mark question because they have not asked so far on the accounting side, right? But let's see as we move forward how it is. For now, please remember these key features and whatever taught so far, alright? And then let's move on to the next, which is total quality management. Very easy. So connected with JIT. It's just about, having maximum quality. Go with the term. Total quality management means having maximum quality. But so that is the feature of it, but you need to know the key terms in it, and that is why I will be going through in detail with you. Alright, so okay, let's focus on total quality management. Okay. So the key feature of total quality management is, as I said, achieving maximum quality. That how to achieve maximum quality? You have to get it done first time itself correctly, right? So no errors, no wastage. That is defined as high quality item. Okay, so that is the first feature. What is it? Getting right the first time. That's how they word it in your book. So just, you can go in your own words, but getting it right the first time. Okay. So that is the main feature. And secondly, continuous improvement. Again, in one day you cannot achieve maximum quality because you don't know the situation. But day 2, day 3, you will learn the process, you will learn the system. As you get used to the system, you realize based on your objectives, how can I improve my process to achieve that ultimate goal? And that is, you need to do that, and that process of doing it is called continuous improvement. Okay. Okay. So just remember these two features. Then let's look at 9 elements of total quality management. Okay, the 9 I would define it as again sub features of a total quality management. Just remember the key terms and the meaning. Okay, first you have, it's very much linked with your JIT system, which is prioritize your customer. Again linked with JIT, right? JIT system also prioritizes your customer like JIT. So JIT also wants to achieve high quality, and so a total quality management system can support JIT, right? Because they both by prioritizing their customer first. And the main concept is, by prioritizing your customer, you are able to identify what quality the customer wants. Then only you can design the quality within your organization and achieve the target quality. And therefore sell the maximum, because you meet your customers' needs. That's the ultimate goal of any company, right? Alright. And then you have improve customer-supplier relationships. Customer-supplier relationships. So this is very important, because if you have a good relationship with your supplier only, you are able to achieve high quality goods, high quality inputs. Then high quality inputs means what? High quality production, right? If you get low quality input to your production or low quality raw material, you won't be able to get a better output. So that is the customer supplier relationship. Then you have focusing on preventing the cause of a defect rather than focusing on achieving a predefined level of quality. So I would say identifying defects, causes for defects. Causes for defects. This means you need to check what is causing the problem. What is causing your quality problem? Based on that only you decide, okay, so if this is causing a quality problem, then I should address it, then it will help me achieve my total quality management. Okay, so that is what it says. Then when you come to the next, they say all employees must be involved. In the tute they have mentioned all personnel to be aware. Okay, all personnel means what? All employees. Right, all employees involvement in simple terms. Okay, just a feature, so that everybody will work to contribute to achieve total quality. That's the meaning. If one person fails to achieve total quality, no point. The process will break and ultimate customer quality will not be achieved. Okay, so every department must work towards achieving quality, and that is why they created even a quality circle. Okay, that is there as you go on, but I'll just mark out by quality circles where a group of employees will be created, right? A group of employees, just nothing, it's just a group of employees who will focus on a daily basis on checking whether they achieve the maximum quality. Okay, so that's on all employees involvement. And then you have the main, I would say, like the key term of total quality management is zero defects, right? Just whenever you remember total quality management, just remember zero defects, because it's very important. It's very not achievable at zero, because nobody can achieve 100% quality, but at least 99%, okay, must be achieved. That is the target. So if we focus 100% only, they are believing that we can achieve total quality management. Then at least practically 99% we will be able to achieve. So that is the meaning they want to give. Hence they say zero defects. Then you have eliminate waste. Zero defects means no wastage. Hence you reduce or eliminate, not even reduce, eliminate. Okay, that means no wastage at all. That's the meaning. Eliminate waste. Right? Eliminate waste. And then requires all departments to get the task done right the first time, which is this key feature. Getting it right the first time. As I told before, all the employees must involve to get it right the first time. If they don't, you don't follow a total quality management feature, and hence you don't ultimately achieve total quality management, right? Total quality in other terms. So that's what they mention. Quality certification programs. I would say, under like quality circles, okay? Like quality circles, you will have organizations can implement actually quality certification programs. Quality certification programs, like example ISO. Okay, I think now you all will ISO 9001, I guess, right? It has the number over here, but if everybody knows what is ISO certification, right? Like it's a certification that is given to assure that your total quality of the organization is achieved. Okay, so that certificate is very valid. It improves the competitiveness of your organization. So that's why whenever they get such a certificate, they display it in their office premises, so that customers get to see it, and customers think, oh, this is a competitive business, a good business, because they produce high quality products, and so they demand for such products. Okay, so that's with quality certification programs. Emphasis on costs of poor quality. Good quality requires savings. Yeah. So they say good quality will bring savings to your business, right? Because of you eliminating waste and having zero defects, you are able to achieve high savings in cost because you have savings in cost. Why is that? Because you have high quality, meaning less correction costs, right? Less prevention costs. Maybe, yeah, prevention I would say no, but correction cost you will have less. How? For example, let's say a machinery, it's working maybe full time. It had an error in itself and then it had a spillover. Now to clean the spillover, you need people and then you need to pay wages, right? So that is a cost for you. So in a wastage creates cost for you. So if you have no wastage, then no such cost for you, right? It's really simple. Just think no wastage, hence increased savings in cost. That is how it links. Alright, moving on. Let's look at the quality assurance procedures of total quality management. Right, that means what type of procedure a company should undergo to ensure that their quality is achieved with what? With zero defects and elimination of waste. Okay, alright, that let's see what are they. The first one, quality assurance of goods inwards. Inspection. It means you have to inspect whatever the goods you receive from suppliers. So it's also very, very practical, okay? Just don't think too much about it. Just be very practical about it, right? So let me clear up. Quality assurance procedures. First one is quality assurance of goods inwards. Meaning you need to inspect the goods that you receive from your supplier. Okay, that is what they generally mean. So warehouse keepers, they do this inspection checking. So when you go for audits and all, you basically check their records. So like they check, they do that three-way matching, right? Three-way matching between your PO, invoice and the delivery note, so that to ensure that the ordered quality is being met by the invoice and is stated in the invoice and delivery note and in the actual goods. Okay, in the actual goods, and that is proven by these two documents, right? So that is how they check quality of the inputs they receive from their supplier. Next let's look at the second procedure, which is inspection of output. So how do you inspect output is, again same, you might have you might test samples, right? Sometimes this is like in your audit subject also, like you might come across testing samples. You don't go to check the entire thing. It will be a time waste, and that waste is also contributing to your quality waste, right? It's because you could have used that time for improving your quality. So now you just spend time to test samples out of the total to ensure that your quality is meeting the specified standard of the customer. Okay. Then you got monitoring customer reaction, that is getting feedback from customer. Monitoring customer reaction. Obtaining feedback. You need to obtain customer feedback in order to see whether you achieved the customer's quality or not. If they say you didn't meet our quality, then they'll say then you haven't met total quality management, right? Total quality management is not there. But if you have met, if it's positive, then your quality is okay. If it's negative, your quality is wrong. So feedback can be positive or negative. Okay. So quality is dropped. Then internal customers and internal suppliers. So that is also same, right, as we previously discussed. Internal people means people within departments, right? So people within departments means okay, so means when you let me write this. Okay, when you transfer goods from one department to another department, the receiving department is your internal customer and the delivering department is your internal supplier. So that is called internal customer and internal supplier, and their quality also must be maintained, right? As we discussed, all departments must have quality, and so internal customer and internal supplier also must therefore show their quality to others by the transfer process, and that's why they define that so they identify it as like internal customer and internal supplier. Okay, internal supplier. Internal. Okay. They must ensure that the quality is maintained well between internal customer and internal supplier. Alright. Then you have employees and quality. Okay. This is a bit a hard thing to do, because making employees, right? I would say how to ensure employees meet quality requirements. Because nobody likes change immediately, right? So to make them change and meet the quality, the organization must, create it in the organization culture, right? So that every employee, because it's required by the culture, they'll tend to comply. Then you have providing job enlargement. Job enlargement means providing more responsibility to the employee so that they, they tend to look for quality errors and achieve it, right? So that is called job enlargement strategy to motivate your employee. Then intergroup competition. Intergroup competition means creating a competition between all the employees so that they try to be the best quality manager, right? They try to say that they are the ones who achieved quality in this year, first, the best department. Okay, so that's how they try to motivate employees to achieve quality within the organization. All right. Then design for quality. Design for quality takes place in two stages. Okay, takes place in two stages. Let me take off this. So as they say, stage 1 is the product design stage. Okay, right. So the product design stage would be, right, first product design stage. That means, simply think, when you are designing your product, you must design a quality product. That is the meaning. So because in designing you will decide what are the raw materials for your product, from whom you should take the item, how you are going to show your quality, because sometimes when you look at a thing you might feel it is of quality, like Apple phones, they are well branded and they are of course quality, but other phones are also similarly quality as them, right? But it's just the way they present and the way they market it. So that is part of your designing the product, right? So there you need to look for quality aspects at the design stage. Then you have designing methods of producing the design feature. Now you might you might design a high quality item, but you will need high quality production processes to meet such quality, right? So that also you need to design. That's called design methods of production. If I am to be precise, methods of producing the design feature. Easy, right? So you design the quality for the product, and you design the quality method, I would say. Quality method to produce that quality design product. Okay. Let me rephrase this. That quality design product. Okay, and then we have support centers. Now this is interesting, right? In costing you have like service centers, production cost centers, and part of it becomes the support centers. So support centers, here they say how to use support centers to ensure the quality of your organization. Again, all surrounded with quality, bringing quality to the business. So if you take any aspect, you must be able to link to take out the quality of your business, right? So here they emphasize two main support centers, which are information systems and distribution systems. Information systems should be designed to get so I would say again, get right information at right time to the right person. Just focus on the word right. All right. Okay, so just remember, what is the function of information system department? That is to transfer information. So if you try to get the right, so if achieving quality in the information system means getting the right information to the, right information to the right person, okay? That's what you need to do. That's the task of the information system department. Then you have distribution system department. What they should do? They should, distribute goods to the right person at the right time. Okay, get right goods to right person. Okay, if they deliver the wrong product to the wrong person, like a person may not order the same product, but you delivered it to that particular person, they'll get annoyed, and that is not quality, because quality is also embedded in the delivery service. Okay, so every aspect people judge quality. So you need to ensure that you maintain quality within every aspect of your organization. That's why it's called total quality management. Total of entire organization quality, okay, maintaining quality, and then management, managing it. And that is where we learned the 9 elements on how to manage it. Alright, so thank you very much. So I hope you all learned well about total quality management. Let's meet at the next video.
Thank you for watching the video. Stay tuned with castudies.lk for more lectures online.